I want to go back to this data I used earlier in this video series on Chapter 6. And again, if you're taking this class, you probably got this from me. Comparison of final exam grades in Math 160. So earlier I did a confidence interval on winter of 2002. Now we have, I'm going to compare the winter of 2002 with the summer of 2001. I think probably I wrote winter of 2001 earlier on the board. It was 2002. Sorry about that. So I have a winter class and a summer class. And I took data on both classes as far as final exam scores. And let's look at it this way. The mean for winter was 77.2. The standard deviation for winter was 13.3, and the sample size for winter was 11. As far as summer, the mean for the summer was 81.0. The standard deviation for summer was 13.9, and the sample size for summer was 14. So I had more people in the summer than we did in the winter, which is unusual. Usually it's the other way around. Okay, so question is are these classes, do they perform differently? Well, on the surface you say, well, of course they did. Summer did better. They averaged 81 on the final exam, whereas the winter class only averaged 77.2. Okay, well, that's looking at it from a point estimate. Looking at it statistically, you want to ask the question, are those two numbers significantly different? Do we have enough evidence to show that the summer class did better than the winter class? Okay. Do we have enough evidence? In other words, are they significantly different? Well, the approach we can use in estimation is to estimate the population mean difference between these two means. Okay, so we're going to estimate the population mean difference. And let's use 95% confidence. So 95% confidence, as usual. All right, well, this, unfortunately, this is a pretty involved calculation. And it's one of the uglier ones that we have in this course. And you'll find it starting on the bottom of page 250, going up to top of page 251. So the title is Confidence Interval for a Difference Between Two Means. Okay, well, the first thing we do is to find a pooled estimate for the standard deviation called simply S. And I've heard that term or read that term in other books. I think our book calls it an average, but it's not a true average. It's a sort of a strange weighted average. So the S that we're going to use, the standard deviation we're going to use for our calculation, is, according to the formula, it's going to be parentheses n1 minus 1 times s1 squared plus n2 minus 1 times s2 squared divided by n1 plus n2 minus 2. Alright, so there it is. And I just, this time for a change, I did not change the looks of the book formula. Alright, so now the formula has subscripts of 1 and 2. Up here I got more descriptive. I call it winter and summer, W and S. It's up to you. And really, which one goes first? It doesn't matter. But I'm going to in this case, use the higher number first. So this is going to be my S1, I'm sorry, will be 13.9, and my S2 will be 13.3. You'll see why in a moment why I did that. I like to take the, for N1 and S1, I'll use the higher sample mean. It makes some sense. It avoids a negative number. If you do that backwards, you should get the same result. Okay. Well, plugging the numbers in, S will be the square root of 14 minus 1, that's 13, times S1 squared. SS squared is 13.9 squared, plus 1 less than this sample mean would be 11 minus 1 is 10. So I have 10 times that standard deviation, which was 13.3. And we'll square that. And then divide by 14 plus 11 minus 2. Alright, so I plugged all the numbers in. And I'm going to calculate it. Well, I'm going to calculate it this way. I'm going to first do the numerator. So I'm going to do 13 times, I'm going to do this whole numerator here. So it's going to be 13 times 13.9 squared plus 10 times 13.3 squared. I'll hit equal. I get 4,280.63. Now I'm going to divide by this number, and it's going to be 23, I believe, because 14 plus 11 is 25. 25 minus 2 is 23, so I'm going to divide by 23, hit equal. I get around 186, and then I take the square root of that. I get 13.6. So actually it's 13.64. Let me go one other decimal place here. 13.64. So is that showing on the screen? Yes, it is. It made it. All right. So now just a little footnote here. The average between 13.3 and 13.9 is 13.6. This produces a sort of a weighted average that's going to be weighted more toward the larger sample size. So because the higher standard deviation came with a larger sample, that's why it came out a little bit more than 13.6. It came out to be 13.64. So that's a number we'll need in our calculation. Now I'm going to have to do a lot of erasing here, and let me write up here that S was 13.64. Okay, and then I'm going to erase this stuff.